Let's say, for example, that we had to find the derivative of the inverse cosecant of the square root of 2x plus 5. Now, what you can see is we have a complex function here, and we're going to need to chain when we do this. So the outside function we can identify as the inverse cosecant. There is a middle function, which is the square root function, and then the inside function is 2x plus 5. Right? So we're going to have to use the chain rule when we do this. We will also need to use the rule for differentiating the inverse cosecant. So the inverse cosecant of x, the derivative of it with respect to x, is equal to -1 divided by the absolute value of x times the square root of x squared minus 1. Okay, so let's begin. If we want to find the derivative with respect to x, we start by differentiating the outside function. The outside function is the inverse cosecant. So we start, this is -1 times the absolute value. The rule says absolute value of x. Now, x is what's in the argument. So we can evaluate that at the absolute value. Our argument is the square root of 2x plus 5. Then we multiply that by the square root of x, but in our case, x is the square root of 2x plus 5. Then that quantity gets squared from the rule, and we subtract off 1. So we have just differentiated the outside function, but now we have to differentiate the middle function. So the square root function, remember we could write this as 2x plus 5 to the 1/2 power and apply the power rule. So the derivative of the square root will be 1/2. Evaluate that at the inside function, which is 2x plus 5. All of that raised to 1/2 minus 1 is -1/2. And then lastly, we can differentiate the inside function. The derivative of 2x plus 5 is 2x. Okay, so that is applying the chain rule. Now we have to simplify, okay? So starting on the left, -1. Now the absolute value of the square root is just the square root because it will always be positive, 2x plus 5. Then this gets multiplied, excuse me, by the square root of, now squaring inside, we'll get the square root squared is 2x plus 5. We still have to subtract 1. Over here, this is like 2x over 1. Excuse me. All right, so these 2's and these 2's will cancel. This 1/2 power I'll make positive by pushing it through the division bar. So this will become this, let's see, 2x plus 5 to the positive 1/2, which is the square root of 2x plus 5. And we're left with just x over 1 for the blue. So what's going to happen is up top we have the -x left, and the square root of 2x plus 5 times the square root of 2x plus 5. Okay, so on the next page I will have to do this. So up top we're left with -x. The square root of 2x plus 5 times the square root of 2x plus 5 is just 2x plus 5. That gets multiplied by the square root. Coming back over here, it's 2x plus 5 minus 1, which is the square root of 2x plus, plus 4. And that's it. So that's how we apply the inverse trigonometric derivative rule for the inverse cosecant and the chain rule to come up with our answer.